Alright, in this section 10-5 we are looking at an introduction to polar coordinates. And so up until this point we've really graphed points using an x and y rectangular coordinate system, right? Where the x is the number of the horizontal axis and y is the vertical axis to give the coordinates for the point. Okay, so this is another way to give coordinates, and it's called the polar coordinate system. Okay, so the origin in a polar coordinate system is called the pole, or the center of the graph, right? And the two different types of coordinates, one is going to be the radius, right, which is the directed distance from that pole to the point, right? And the second coordinate is going to be the angle, right, the directed angle. Okay, so instead of having a horizontal and a vertical coordinate, then you've got a radius and an angle coordinate that kind of shows you the location of the point. Right, so that's basically the polar coordinate system in a nutshell. And so, like as you can see here, the radius would be this distance to the point, and basically you can, when you're plotting it, you can come out there first, and then you can go up the angle to that point, right? So what we'll do is we'll practice plotting points in a polar coordinate system so that we can become familiar with it. And so let's say that this point 2, pi over 3 is in polar coordinates, right? So remember, the first number is going to be the radius. Okay, so again, on the polar coordinate system, you've really got different circles representing a different radius, right? So if my radius was 2, then I know my point is on the circle that has a radius of 2 from the pole somewhere. And where is that point? It's going to be pi over 3 radians up. Does that make sense? All right. And so there would be the point. Okay, so that would be an example of how to plot the points on the polar coordinate system, right? And so again, we've got some more examples. Where would 3 negative pi over 6 be? Well, 3 would be on the circle whose radius is 3 away from the pole, and then the angle would be negative pi over 6, which would end up being here. Okay, and then the next example, 3 and 11 pi over 6, and then notice in the last example, since it was negative, that's why we went clockwise. And so here we would go 3 again, and 11 pi over 6 happens to be the same angle as negative pi over 6. So actually, these two coordinates represent the same point. Okay, these two coordinates represent the same point. Okay, here and here, that's really actually the same point. These two. All right, and that's the point they're making here. It coincides with this point, as you can take a look that it's in the same location. All right, so unlike polar coordinates, where each coordinate is a unique point, okay, or I think I may have said that wrong. Unlike in rectangular coordinates, where each coordinate is a unique point, in polar coordinates, okay, you could have two different coordinates that represent the same point. All right, so that is possible. That's kind of what the discussion gets into here. Okay, so again, in rectangular coordinates, each point xy has a unique representation. That's not true in the polar coordinate system. For example, r comma theta and r comma theta plus 2 pi, that represents the same point. All right, and we kind of saw that in the last example. And so there are actually infinitely many coordinates to represent the same point, because as long as you add a multiple of 2 pi to the angle, you're going to end up at the same place, much like the circular nature of the angles on the unit circle. All right, so we've kind of been exposed to that, ever since the first semester of the course. Right. So also another way to generate the same point would be to take the radius, make it negative, which means you'd go the opposite direction. So like for example, on this one where we go 2 pi over 3, that means we go forward or to the right 2 and then up to pi over 3. So if this was negative 3, right, if you made that negative, then you would go back let's see, negative 2 you would go back to and then use it. So it's kind of the opposite direction. And so if you change that R from a positive to negative, change the sign of it, you would go the opposite direction before going up the angle. And as it turns out, if you change the radius, the sign of the radius, and then add pi to the angle, right, instead of pi over 2, you would actually still end up at the same point. Why? Because when you change the radius from positive 2, say, to negative 2, you've already accounted for 180 degrees. So instead of having to add 2 pi to get back where you were, all you have to do is just add pi, right? And so that's kind of the reasoning behind that. So generally speaking, in order to get the same point, you can take a polar coordinate and you can add or subtract any multiple of 2 pi to get the same point, or you can take the polar coordinate, change the sign of the radius, and then add or subtract 2n plus 1 multiples of pi to that angle to get the same point. And if you think about it like this, here's what kind of happens here. And so if this n is 0, right, if this n is 0, then that's just adding or subtracting 1 pi, right? Because remember, you already pick up 180 by changing the r to negative. So if you add 1 pi, you get the full 360 all the way around. And then again, odd multiples. So like if this is 1, 1 times 2 is 2, plus 1 makes 3, you'd have to add 3 pi. So after you added pi to get all the way around again, you'd have to add 3 pi, another 2 pi to it to get around. All right, so that's kind of the way it's, the reason why it's described the way it is. All right? Okay, so what type of problems are we going to be faced with from this section? Okay, what we're going to do is, okay, we have a point here. Okay, it says to plot it, but we don't have to draw a graph or anything to plot it. What we want to do is we want to find 3 additional polar representations of this point, okay, that fall within negative 2 pi to 2 pi, all right, as far as the angle is concerned. Well, how can we do that? Well, the first way that we can do that, as we kind of discussed, would be to, and we have to be careful, I can add any multiple of 2 pi or subtract any multiple of 2 pi from the angle. Now I have to be careful which one I do, whether I add or subtract 2 pi, because I am restricted to this interval. So I don't want to subtract off 2 pi here, because that would put me below negative 2 pi. But since this is already negative, I can add 2 pi and be under 2 pi, so that's what we're going to do. So if I take this coordinate, 3, negative 3 pi over 4, and if I add 2 pi to it, to the angle portion of the coordinate, then that now becomes 3, 5 pi over 4. All right? And so that is another polar coordinate to represent this same point. How did we do it? We had to add 2 pi to the angle. That's how we got that. Okay, now it says find 3 that are within this interval. So there should be 2 more ways to do it, and there are. The next way would be to change the radius, the sign of the radius, from positive 3 to negative 3. Then I can take what was here, negative 3 pi over 4. All right, and I can add pi to it. All right, and when I do that, I would end up with negative 3, and then adding 3 pi over 4 plus pi, I can make that 4 pi over 4, and then that would end up being pi over 4. So there's another point that represents, or another coordinate that represents the same point. How did we do that? We switched r to negative r, and then add pi to theta. All right? And one more way to do it would be to change the sign of the r and subtract pi from the angle to get negative 3, so negative 3 pi over 4 minus pi, that'd be negative when you make a common denominator and subtract it. That'd be negative 7 pi over 4. Negative 7 pi over 4. Alright. And how did we get this? R changes to negative R and subtract pi from your angle. Alright? So that's kind of an example of how we can take a coordinate and we can find other coordinates that represent the exact same point in polar coordinates.